Hi everyone, and welcome to my talk, the GCP Jenga Tower hacking millions of Google servers with a single package and more. What if I told you that the requests that you see here are from internal Google servers? That was the moment I realized I ran code on all of these servers, and I can potentially run code on millions of Google servers. That was without any interaction at all until I got blocked. And guess what? Google was not the one who was responsible for blocking me. So please say hi to the Cloud Imposer vulnerability. An RC vulnerability I discovered in the GCP Composer service. Supply chain attacks, we all know them. They are dangerous. But supply chain attacks in the cloud are something different. They are boosted, kind of like on steroids. For example, if we take one malicious package that will be deployed in an on-prem server, that one malicious package potentially will only affect that on-prem server, as opposed to one malicious package that would happen to be deployed to a cloud service that will be deployed to millions of users. Just imagine the blast radius of such an attack. So before we get into Cloud Imposer and the technical details, we should speak about the prequel. The prequel to the vulnerability is an attack technique that is named dependency confusion and was first discovered by a guy named Alex Bearson. So we will take a practical example in Python. An innocent user or an application wants to install a private package from a private repository. They will usually do so with the following command: pip install --extra index URL and specifying the private registry. What they don't know is that behind the scenes, pip, with this argument in that case, not only will search for the private registry, but will also look for PyP, the public registry. So in that case, an attacker can seize the opportunity to upload a package with malicious code inside, but with the same name to PyP. And now pip is very, very confused, because it sees two repositories with two packages, one malicious and the other one isn't. But it can't differentiate, right? In that case, the assumption was that it is all based on versioning. So in the Python example, as you can see in the left bottom of the screen, there is the requirements.txt file in Python, which specifies that the legit package has to be with a version that is greater than 0.1. The legit package has the version of 0.2, and the attacker's package will upload a version of 0.3. In that specific case, the attacker just hijacked the package installation process of the victim because the version is greater, and boom. The attacker just executed remote code on the target, as simple as that. So this is dependency confusion, but please bear with me because Cloud Imposer is a unique case study of dependency confusion, something you have not seen before. So let's continue. We can conclude that package managers are dangerous. I gave you an example of how it works in pip, but I can assure you that there are other case studies in package managers like NPM and Go and other package managers that are also vulnerable to this kind of stuff, to dependency confusion attacks and risks. So, last teaser before we get into the technical details is let's align on what exactly is GCP Composer, the vulnerable service. So very simple. If we combine Google Cloud and we also compile the Apache Airflow system, we will get GCP Composer. To those of you who are not familiar, the Apache Airflow system is a system that handles data pipelines, workflows, and such. So GCP Composer is essentially a managed version of the Apache Airflow system. Very simple. This is all you need to know. So let's get into it, the fun stuff. Cloud Imposer. It all started here, in this following documentation page. So when I researched, I stumbled upon this documentation page. And when you deploy the GCP Composer service, what happens behind the scenes is that Google takes an image of the Apache Airflow system. I remind you, GCP Composer is a managed version of the Apache Airflow system, so it all makes sense. But they also bundle it with, guess what? PyPI packages. And we now know how package installation can be very risky because I just showed you the risk pattern. So in that specific case, you can see in the documentation that I can see the PyPI packages, and I will tell you that some of these PyPI packages are internal and private. So my idea was this thing. These packages are actually pre-installed. It means that if I hijack one of these packages or dependencies, I can potentially abuse GCP Composer and hijack a package that will be deployed and pre-installed on each and every GCP Composer services in the world. Because each and every GCP Composer service uses the same image that uses the same package. So that will be an absolutely crazy scenario and a vulnerability. My idea was to simply go ahead and scan the packages. So I obviously didn't use this awful looking code. This is just a mock-up. But the intention of the code was to simply go ahead, take the list of dependencies from the documentation, and try to find if any package is missing from PyPI, from the public registry. And if so, I might be able to hijack it. And then this happened. Boom. Google Cloud Data Catalog Lineage Producer Client. This specific package, an internal package of Google, gave me 404 from PyPI. It means that this specific package is missing from the public registry, and I can possibly hijack it. The next step for me was to delve into the GCP Composer file system. Well, as an ordinary user of the service, I can do it. It is as intended in the cloud. I can run code on my own service as long as I don't access other customers' data. So I kind of abused this feature, this as intended feature, and I ran code on my own file system in order to grab the package name that I just found that is missing to try and reveal some metadata or anything that will help me to discover how is this specific package is being installed behind the scenes in the service. And I will read it out loud. I found a metadata file that was very, very interesting at that point of the research. It says, pip install -- extra index URL, Google's own repo, and the Google Cloud Data Catalog Lineage Producer client. Amazing. So we now have all of the ingredients, right? We have the extra index URL that is potentially being used by the GCP Composer service that we now know how risky it is, and it also looks for PyPI, the public registry, right? And also, this specific package is missing from PyPI, so I can upload a package with malicious code, but with the same name to try and confuse the process of installation. But guess what? It was not that easy and not so fast, because this specific package is actually version pinned. I went back into the documentation, and I saw this specific message, this specific documentation that claims this specific package is version pinned. So let's confuse it even more. So again, we go back to the example of dependency confusion, but in that case, this is on GCP Composer, on a Google Cloud service. So in that case, instead of an innocent user or an application, this is basically the GCP Composer service that uses this following pip install. Again, a risky argument, the extra index URL, which tells pip, please look also in PyPI. And then pip again is very, very confused. And now it has to choose between the attacker's package, my package, or the package of Google, the internal package from the private registry. And that specific case is so interesting and unique because in that specific case, the versions, the package versions are the exact match. And also the names are the exact match. So there is no package that has a greater version. So who will pip choose in that case? So I'm going to tell you a secret. If pip wouldn't choose the package of the attacker, I would simply not stand here on the intent stage. So in that case, again, pip chose my package, the attacker's package, even when the versions are the exact match. That is absolutely crazy. Okay? I kept researching, and I saw this following GitHub issue back from 2018 by a user named Felix. And this user claimed, what is going on? I use pip install with the extra index URL argument, and public pipey is always prioritized, even when the versions are the exact match. What is going on with this behavior? The answer was basically, this is not likely to change. This was a response by a member of the Python Software Foundation. This is a behavior that still happened to this day. We are in 2024, 6 years after, and basically, I believe no one knew about. Very risky. The next step for me is to go ahead and craft the POC. I created a malicious package. Again, this is a mock-up code. The intention of the code was to validate that I actually executed code on Google servers when they installed my package. How? By sending HTTP requests to my external server or DNS lookups. So this is how it looks like. This is my Python package that is named Google Cloud. Then I uploaded the package to Pipey with the same version and the same name. And the next and final step is to see all of these requests and be so happy because I just realized I executed code on Google internal servers. Thank you. And then this happened. Sorry, something went wrong. Pipey is down for maintenance or is having an outage. And I'm going to tell you another secret, just between me and you. Pipey was not down for maintenance and also was not having an outage. What happened is I logged into the user that I just uploaded the malicious package from in order to delete the package, because in order to comply with the bug bounty rules, I had the POC, I ran code, I don't need it anymore, right? I will just delete the package, I have the POC. But I saw this message. Turns out that Pipey actually blocked the user that I uploaded the package from and the package that I uploaded in a matter of maybe minutes. I had two speculations. First, there is a defense mechanism I'm not aware of personally, or there is a Pipey partnership with Google. So this is also an interesting case study that if you want, as researcher, you can keep on researching. As for the disclosure and fixed, Cloud Imposer was confirmed and classified as a remote code execution vulnerability. Google fixed the vulnerable script that was utilizing this extra index URL risky argument we have talked about, and they also checked the checksum of the vulnerable package instances. Google said that there was no evidence of a vulnerability exploitation in the past of Cloud Imposer. So this is good news for us. But if we go beyond RC, beyond remote code execution, we can speak about Jenga. So again, the talk title is the GCP Jenga Tower. Why? Because I just revealed a concept that is present in the major cloud providers. Some of them is Google Cloud, GCP. The concept says that cloud providers build their services on top of each other. It creates risks and also opens the door for attackers. For example, we can apply the Jenga concept on the GCP Composer service. And while researching GCP Composer, I realized that it is actually built behind the scenes on another Google Cloud service. And this is the Google Kubernetes engine, as you can see on the screen. So while we apply the Jenga concept, we can now think to ourselves as researchers or attackers or even defenders that there is a unique attack path that we couldn't know if we didn't apply this concept. So we can apply the concept and now use unique privilege escalation attacks and vulnerabilities that are specific to GKE, the Google Kubernetes engine. So just think about it. This is just one case study of the Jenga concept, but the cloud is full of services that create other services behind the scenes, and we can abuse those as researchers. So just think about it. If you want to learn more about this specific concept, or even the Cloud Imposer vulnerability, make sure to visit our blog because I didn't have much time to cover it all. there are also more details about it, and I assure you these are interesting details. Wrapping up, we will wrap up by claiming that cloud providers are actually not bulletproof. They sometimes get it wrong. We saw it in Cloud Imposer, we saw it with past vulnerabilities, and even with a couple of critical vulnerabilities in AWS that my friends from Aqua Security will reveal later on this stage. And just know that there is the shared responsibility model. You own your services, but sometimes you cannot control what is going on in your environment. Just know that cloud providers are not bulletproof. As for supply chain attacks in the cloud, they are so dangerous. Like, just imagine how many vulnerable users will be and get affected by Cloud Imposer if we will deploy this package and it wouldn't get blocked, if we use stealthier techniques in order to actually abuse this service, the GCP Composer service. It will potentially affect millions of servers because it affects each and every GCP Composer service that deploys the default image. And it's almost everyone. As for dependency confusion, please beware. We saw that the dependency confusion awareness is very, very slim. We just executed the dependency confusion attack on one of the most and largest companies in the world, Google. And we also saw this GitHub thread from 2018 that someone claims about this issue, the dependency confusion issue, and actually, no one took any action to mitigate it. So please beware and know and investigate the package installation process in your organizations in order to stay safe. Thank you very much for welcoming me into the Instant stage. If you have any questions, please feel free to reach out. I'll be around. Thank you.